Hello. Hey, hello. Good morning. Good afternoon. Wherever you guys are. Hopefully, you've been having a good day. I woke up a bit early, but that's fine. Lately, there hasn't been anything that's happening on crypto, right? So, it's just been chilling. I guess everyone is chilling for the holidays and stuff. So, I'm doing that a bit too, I guess. Other than that, just busy with end of the year stuff. Okay. I took a look at Twitter this morning, but there was anything interesting that was happening, so I think we could just jump right in, right? Let's see. So I'll start with how I started with MEV, because this is my first ever bot. So let's see. I actually brought out my my Wacom. Yeah, I brought out my Wacom tablet. So let's see. Okay. Yeah. So I started in, what is this, 2022? Don't like how that looks. Let's see if we can. Yeah, I started in 2022, so I just quit my job and then I went like full time. You could say full time, and then let's just doodle for a bit. Yeah, I started in 2022, I think April, and then once I started, it only took like 1 month before I was profitable. At the time, this is still like just like, I don't know if what range would people consider DeFi summer at the time. Yeah, this is probably like at the tail end, but what was happening here was that there was a lot of alternate layer ones that were releasing. So I started first on Metis. So Metis is a layer 2. We'll talk about it in depth, but Metis is actually I don't know, the mother of Vitalik Buterin is the one spearheading Metis. Don't ask me about it now. I have no idea, but I remember that. Yeah. Okay. So I think we'll just jump into the code, right? And then I'll talk about each. We'll go line by line. We'll go in chronological order. I made it a bit bigger so it's easy to see. Yeah. What I decided, I was working as a manager at the time for an electronics company. And I was like, okay, maybe I'll do this MEV stuff for a bit. I gave myself 6 months and it worked out. So, and here we are today. Yeah. So I think the GitHub is in the Twitter link. Oh, I should say, let me send a tweet. Yeah, but the GitHub is on Twitter, so you can get it there. Let's see. Let me just send a tweet out. It's very old. I think this is when I was still learning Go. And what I wanted to, there has been some improvements here. So, but it's not like, okay, it's not like my latest ones. Yeah. I can talk about that more a bit. Okay. Some of the imports, right? So gen here is actually a generated code. So if you are not familiar with ABI gen, right? Let's do this. So basically, Go Ethereum has this thing called ABI gen. So what it does is it takes in Solidity. Using ABI Gen, you can get generated Go code. And this generated Go code basically is like the exact copy, not to say copy, but what did they call it? A binding? A binding to the Solidity. Yeah. So in my setup, what it does is, what I do is, can we do this? Basically, I have a bot folder. How do you do that? Okay, a contracts folder. This contracts folder has Solidity, right? And then I feed this into ABI Gen, and then it comes out as in Gen. Yeah, let's do this. It's easier. And then I also have a hard hat export. So what hard hat export does is it outputs a JSON, which is, I think it's like chain ID. Let's see, it's something like chain ID. My writing is horrendous. Let me just, I'll use it if I want to draw. Let's see, I want to drag this. So hard hat export, it outputs like a chain ID, an object chain ID into contracts. Yeah, something like that. And so this goes into like, I don't know, deployments.json. So I am able to deploy on multiple chains. And when I run the bot, it uses the current chain ID from the RPC to know where are my contracts. Yeah, so this is my pipeline, you can see. Solidity to ABI Gen to generated code. And then I have an export that exports all the deployments that I have into here. Yeah. Yeah, I think this is it. Wait a minute. I'm not sure is this Solidity or ABI? I don't know. I'll just write here. Yeah, either Solidity or ABI. So when you see Gen, yeah, that's pretty much it. I don't know how others do it. There's lots of ways to do it, I guess. But yeah, anything with Gen is generated code using Go. I also have some libraries that I use. This is my own. Yeah, so lib is just my own libraries. It's not like public libraries or something. And yep, I use the Go Ethereum here. Okay. Also, I don't know if you guys are familiar. This decimal here, I think it's pretty popular. I don't know. I stumbled upon this like once. There was someone who posted some code, like utility code, where there's functions that are commonly used, and one of them or that package use this decimal package, and this decimal package is like so I use it a lot. I don't know if this is the case for everyone, because big int is a bit cumbersome or troublesome. Yeah. So yep, that's it. Okay. This bot is part of a bigger bot, and what I have is a config file, which I can set which bots I want to run. And so if it detects the configuration, the right configuration to enable a specific bot that it'll run this function. Yeah. So this is the main entry point. We are at the main entry point. There's some stuff with messaging. I thought I wanted to do like one instance of the bot can run multiple bots, but the applications of that are not. I haven't really used that fully. That idea fully, so it ended up not doing anything, but that's fine. Okay, we have a logger. I have a wait group just so that the main, I guess the parent, knows when all the child bots, which is this instance here, has finished running. I have some configurations. So some configurations are specific to arbitrage bots. Some are different for others. I just get them here, get all the configurations, then I log it. Yeah, very, very simple so far. Okay, here are some constants, but I think we'll go over that in a bit when we run into them later. Okay, I do some more logging. This is very simple. Okay, this is one part that's interesting. This is how you would instantiate a client, right, with your RPC URL, and you would use this instance to query like blocks and stuff like that. The idea I had at the time was that, okay, probably we can touch on Metis for a bit. I'll go into drawing, right? So Metis actually is a layer 2. It's a bit different from, let's say, your other layer 2s. Let's make this one right? Okay, whatever. Okay, so for example, for optimism, you have one block. One block has multiple transactions every 2 seconds, I think. Yeah, but on Metis it's different. It's one block has one transaction, and it comes, and the block is mined when transaction is received. So it's quite different, right? One block is one transaction, and it is mined when the transaction is received by the sequencer. So you can imagine that speed is very important here. You want to be able to react very fast to any transaction. Okay. Now, Metis also had a WebSocket. The sequencer provided a WebSocket, and with this WebSocket you can subscribe to pending blocks. Pending blocks is just like pending transactions, right? And also logs or events, right? So I was testing out whether it had both HTTP and WebSocket, right? I was just testing out which is faster. Like, is HTTP, if I send a transaction to HTTP, is it faster? Or if I send to WebSocket, is faster? Hello, Rasmus. Yeah, thanks for coming in. So I was testing out, can I be faster if I send via WebSocket or HTTP? That was just one of the questions. And so if you look in the code, I'll jump into the code. This part right here is basically deciding whether do I want to use the same client to read and write, or do I want to use different clients for reading and writing. So this is one part. I think I did some testing and I found out that it didn't matter. So I stopped using this part of the code later on, but it was something that I was experimenting with. I don't think it matters nowadays, probably. I'm not that good into computer science, but probably latest HTTP is already quite fast and as good as WebSocket, I think. Yeah. So this is the rationale behind this part of the code, right? This is just how, so we'll be using this read client a lot to read data. Yeah. Okay. We can move on. Nothing else here. Okay. So here, I think we can jump into some Uniswap V2 stuff, right? Here is some code which gets an instance of the Uniswap V2 factory. We can jump into like Uniswap stuff for a little bit. Yep. Are you still doing MEV in today's landscape? Yes, I am. Yep. Just not arbitrage anymore. I'm doing other stuff at the moment. So that's why I'm able to share this bot that I did in 2022, right? So in Uniswap V2, there's a factory, and this factory deploys pairs or pools, I guess. I really don't like it. I can't make it even lesser. I'll write it out. So Uniswap V2 has a factory, right? And this factory manages pairs. Each pair has an index. So yeah, okay. Yeah, each pair has an index, so you can query all pairs using the factory, right? So there's going to be a lot of pairs. Okay, let's jump into just one pair. I want to show you guys something. So what I did at the time was, sometimes some pairs are not verified on chain. So verified meaning that I only have the bytecode to work with. I don't have the actual code, just the bytecode. But I got so used to reading the bytecode that I'm able to identify specific parts of the compiler. I was able to catch specific parts of the code. For example, let's just bring up one pair. For example, so in Uniswap V2, okay, although this is verified, I'll just take the bytecode. In Uniswap V2, at least the basic one, or the original one, the fee is 0.3%, right? It won't give me the code. Okay, let me see. Whatever. Maybe we'll go to Etherscan. Sorry about that. So in Uniswap V2, the fee is 0.3%. This is hard-coded inside the code. Some forks on other chains, they may want to change that fee. Let's say they want to be competitive, so they reduce it to 0.25%, right? And sometimes they want to be dynamic, like they want to be able to set the fee specifically for specific pairs, right? So if you have a USDC ETH pair, it has to be it can have a higher fee or a lower fee depending on how you want to structure your protocol, right? So sometimes I only have the bytecode to work with, but if I decompile it, I can know that this var13 here, let me make this bigger actually. This var13 here is the fee. Yeah. So you see here, this is 0.0x03, right? Which is 3. But sometimes you'll see, what's this? X2 decimal. Sometimes you see 0.03, right? 0x03, which is 3. But sometimes you see, what is it? 20, 19, okay, sometimes you see this 25. Why do you see 25? Is because in the original code, is using 3. Oh shit, I said click. Okay, in the original code it used 3 over 1000. What is 3 over 1000? 3 over 1000 is 0.3%, right? If you just do this, right, it's 0.3%. However, if you wanted to do 0.25%, you can't do it here. You can't do it per 1000, right? Because if you do like 25 over 1000, it's actually 2.5, right? You can. So what they do is, instead of using per 1,000, they use per 10,000. Right. So by using per 10,000, you can get 0.25 like this. Yeah. So that's why sometimes you'll see 0.19, which is 25 in this specific line of the code. Yeah. And sometimes you see a variable. Oh, I accidentally clicked there. Let me just... Yeah, sometimes you see a variable like this one. If it's a variable, then it's dynamic. So if it's dynamic, you need to grab the fee somewhere. It's either in the pool itself or in the factory code. Yeah. The next thing I wanted to show is I also know where is the function signature for the callback. Just this one. Yeah. So in Uniswap V2, there's this thing called flash swaps. And flash swaps, the idea is that you can borrow the money. Can I make this bigger? Hopefully you guys can read it. The idea is that you can borrow the money in order to do the swap. This thing here. Yeah. So there's this idea that, okay, if you want to do this swap, I'll send you the money first. And once you're done, I'll check if you actually completed the swap. Hello, forever. Hey, good morning. So this call here, it tries to call this function in your own contract. And we'll see that later when we move on to the solidity part. This one will yield a different function signature, right? So let's see. Let me just fill this up. Am I doing it correctly? Oh, okay. There you go. It's a bit small. Maybe I can make it bigger. So the function signature is just the signature, and then you do a catch to 56, you get this, right? And this is here, is what you need in the function. Now, some pairs, there's only bytecode, and sometimes it's different, right? It's a totally different function signature. So you have to figure out what is the function signature that they use, right? Like for example, some forks. What is this just now? Tethys. This is Tethys, right? So sometimes they will change the name, like Tethys call. So by changing the name here, you actually change the whole function signature. Yeah. So this was a problem. Like, okay, I don't have money. I am specifically using flash swaps, but I need to know what function they are trying to call on my own contract. So one of the things that I did was just guess the thing. You can try and guess the name that they used, and try and see if it's, is this correct? Maybe this is V2, and you double check this with here, right? You just want to match this, right? One technique that I did was I tried using the error messages. Let's see, is there any error messages here? So if I do a hex to string, right, and I take like this, I assume this is an error message. Let's see, convert. Okay, this isn't. Let's find one. I think there should be one close or nearby. This one? No. Which one is it? It can't be that one. So I'm just trying to find a string in here. There should be one here somewhere. I don't think it's this one. It looks too... No, it isn't. We'll try and find for a little bit, but if we can't find it, I think you guys can imagine the error message. Let's see. Okay, it's okay. I can't find it, but essentially what I'm trying to look for is... oh, it's not in here. Okay, what I'm trying to find is this. Yeah, this Uniswap V2K. Usually, the protocol will change this into their protocol name. And based on the name here, I can try and guess, make educated guesses on what this is. Sometimes I have to guess, sometimes it's just hook. Yeah, things like that. So this is one of the things that I can do now from my time with Uniswap V2, unverified code, just raw dog the bytecode or the decompiled bytecode and just find. I know exactly where the fee is because this is important. You need to know the fee because you want to calculate how much should go in and go out, and the function signature for the callback because I only use flash swaps at the time. Yep. So that's it. So back to the code. Essentially, this code is getting an instance of the factory of the Uniswap V2 forks I'm trying to arbitrage between, and I'm just getting the fee. Yeah, that's pretty much it. Yeah. So important to get the fee and to update it. If you are hardworking, you can like set an event, listen to events where the fee changes. But I was a bit lazy here, so I just took it. Have I seen the fee change? No, I don't think so. Yeah. So usually when protocols, they just set it once and then they're like, they forget it. That's most of the protocols, I think. Right. So here you'll see this fee per 10,000s. When I use fee per 10,000s, what I mean is this here, this 10,000 here. Yeah, this is what I meant. Okay, there's actually 3 contracts that I use here. I guess we'll take a look at it when it comes. This is basically me getting the address of my 3 custom contracts. These are my own contracts that I deployed on chain, and I'm just getting them here. Yeah, and then I instantiate the contract. So now I'm able to use the contract here, like to query data or to send transactions. Yeah, this is what's going on here. Okay, this part is setting up the private key. This should be very straightforward. There's a lot of when I was doing my bot at the time, there was a lot of repeating code, and this is one of them, like just setting up the private key. So I made things a bit more modular now, but yeah, this is what it looks like to set up a private key. When I say executor, I mean the address that I'm using to send the transactions. Yeah, that's what it. Yeah, that's what it means when I say executor, which is just the EOA, the externally owned address that I'm using to send transactions, and it has funds to pay for transaction fees. Okay. I get the gas price here. Okay, there's a calculate min profit. So I guess we can take a look at that. Okay, so when you do the arbitrage, you need to have a minimum profit, right? Because you don't want to execute an arbitrage that you lose money, or at least you don't want to try executing it. So it's very simple. The calculation is basically just what is the gas that I'm paying, and what is the failure. This is the failure. So let's say one Uniswap swap is like 200,000 gas. And then what I do is I just calculate how much I lose, and then I multiply it by a buffer. So let's say you lose, you only win like 1 out of 5 ARBs. What I can do is I can set it so that the ARBs that I do win are offset the cost that I'm paying for all my failed transactions. Like here, I set it to 20. So at least if I win more than 1 out of 20 ARBs, I'm profitable. Yeah. So I use buffers a lot. This is just as a safety net to make sure that I'm profitable. If you want to be more risky, you can set it very low. But I used to set it pretty high. This bot specifically doesn't try to win everything. It just tries to win sometimes, and we'll see that in the code later on. There's also a follow-up here. I'll talk about follow-ups in a bit. Yeah, this is what I named it. We'll talk about it in a bit. Yeah, so this is just calculating the minimum profit, right? Okay, and then here I'm setting up the auth instance. This auth instance has your nonce and stuff, your nonce, your gas limit, the gas price you're paying. So I'm just setting it up here. Nonce is quite an issue in crypto. Yeah, a lot of like funky stuff happening, different stuff happening on different chains. Yeah, it's a bit annoying. Okay, and now we are initializing the market data. Okay. So this is the main function that grabs all the information. I don't think I can, I'll explain it more easily. Yeah. In here. So we have a Uniswap V2 factory. What I do is I grab all the pairs. So from all the pairs, I only want the WETH to token pair, right? I don't want the USDC WETH and other stuff, right? What I want is just, or what I mean is that I don't want like USDC token or USDT token pairs. I just want WETH pairs, right? So once I have WETH pairs, what I do is I classify them in groups of the token. So let's say in token A, there's like 3 pairs from 3 different forks. In token B, there's 4 pairs, right? So now I have a group of pools for a WETH token combination. Maybe I'll write WETH here. Yeah. And then, so from here, what I can do is I can try to buy and sell between the pairs. Let's say I have all the information, right? Oops. I have all the information. What I can do is I can just try, or I can just compare prices. And when I think there's a difference in price that can be arbitraged, I do it, right? But this is how the structure is done here. So this part of the code is specifically getting all of the data for all of the pairs, but only the WETH token pairs, right? So for every Uniswap V2 factory address, I query in batches. You need to do it in batches because if you don't, so every query has like a gas limit, and if you don't batch the thing, like if you try to get everything instead of like get 100 each time, you're gonna get reverted because it's gonna go through. It's gonna hit the maximum gas limit, I think. So this is just getting all of the pairs. There's one protocol called Hermes. What they do, they are a solidly fork. Solidly fork use the same code or the same pair code for both volatile pairs and stable pairs. I don't want stable pairs because you're not gonna get far arbitraging that, right? It's just gonna be like stables. So what I want is mostly the volatile pairs. So this is what I'm doing here. if this is a Hermes protocol, I don't take the stable pools. I just take the volatile ones. Okay, here I try to find is WETH the token 0 or token 1, and then I add it into the index. I also have some, I check if it's a banned token. So banned tokens are like tokens that I had issues with, and I'm like, okay, I'm not gonna arbit. Either that or, you know, it's like a trap made by someone where it looks like you can arbitrage it, but when you send a transaction, you can't. So I just banned those those tokens. Okay, I don't know why there's a hard ban here. What is this? This is interesting. Let's take a look. Why am I banning a specific pair? Can I search it here? It's not here. Can I search it? Let's go to Metis. This is a... No, this is a token, right? Okay, let's look here. Monk. Okay, I don't know why I banned this, but yeah, apparently there's some issue with this token, so I'm like, I'm not gonna deal with this. So that's why there's a specific ban here. So once I grab all the data, I just put it into a struct, and then I add it into my into a group of all of my pairs that I have. Okay. Yeah, that's pretty much it. So here I grab all of the information. After that, what I do is update reserves. So again, you need to do this in a batched way, because if you try and grab everything, it's going to be very difficult. You're going to hit the max gas limit. So here I'm just grabbing all the reserves, again in the same fashion. I only use this once, because after this, after I get all of the reserves, I actually filter everything. So I need the reserves in order to know how much liquidity there is, and when I do the filtering, I have like a minimum liquidity amount that I look at. Right. So here I filter everything out. Everything that I don't want, I just filter out. So I make sure the liquidity is enough. I don't want to like, you know, a dollar amount of liquidity. I remove all the pools that don't have multiple pools. So because if there's only one instance of that token WETH pair, then I can't arbitrage it, right? And then I do this thing called a health check. So a health check is a honeypot checker. This is not special. I actually took it from a public repo. At the time, it's called Token Providence. The exact same name, yeah. Yeah, this one. I remember I took it from here. I took inspiration from this. I didn't copy the code 100%, I think, but the method is simple. You try and buy, and then you try and sell, and you simulate that. So this is what this is doing here. Token is healthy. We can take a look at the solidity actually. Let's take a look at some solidity. So this solidity is for health check. Yeah. This function should be called off-chain. Yeah, you don't send a transaction, you simulate it off-chain. Even though this isn't like a view function, you can run it off-chain. Multiple ways to do this. This is one of the things that I struggled with when I started, because it is hard to find like resources for this. So let's see. Okay, yeah, I buy the token, check how much I got, and I sell the token and check how much I got. I think there's a minimum amount. Yeah, I calculate on chain using get amount out. So when you use get amount out, you get the expected number of tokens, right? And this assumes that there's no like internal fee. Like, you know how in shitcoins they can put like a 5% fee, 5% buy and sell fee, right? So I didn't want to deal with tokens that had fees, but you can if you want to. I think all of the major competitive arbitrage bots nowadays, they handle fees just fine. Yeah. But this part also checks if it's a honeypot. So you can buy, but you can't sell. That's a honeypot, right? So I don't want to deal with that. So this is the health check. So I filter all, I check every token to make sure that it's good. And then that's good, yeah. Okay, there's a sort markets here. This is a bit interesting. So one of the ideas I had to make the bot faster was, let's say, so one of the ways I tried making the bot faster was, let's say I have a lot of pairs, right? Let's make a beaker. And this beaker represents the liquidity, the amount of liquidity. Or maybe this is a bit confusing. Let me just liquidity. Okay, let's just use the beaker for now. Let's say we have different amounts of liquidity in different pairs, right? One of the ideas I had was, if I sort it in, if I sort it in order of descending liquidity, I can do this thing where I start comparing from the most liquid to the least liquid, like that, and I go like that, like that. If I do it this way, if I detect an arbitrage, let's say this one is good, or this one is good, I know that I don't need to check these ones because these ones are less profitable. Why? Because the liquidity we're working with is lower. So let's say I want to be super fast. I can just, if I order it in descending order and I check from the most liquid to the least in this order, the first liquidation that I find is going to be a lot more profitable than, so this is going to be more profitable than this. Why? Because I sorted it in descending order. So when there's more liquidity, you can put a bigger size, you can arbitrage a bigger size. So this is one of the ideas that I had. So that part of the code, sort markets, is actually sorting within a descending liquidity. So this is one of the ideas I had. Again, speed is important in Metis, so that's why you have this part called sort markets. Let's take a look. I think it does do. Yeah, it sorts it by the reserves. Yeah, that's one of the ideas that I had. So sharing it out. Yeah. Okay, I think we can continue this one. I don't think we need to look at it. It's fine. Okay. This part is, so what I did here is that when I do all the data collection, I save it. If I want to replay something, I can use debug mode to kind of just load everything from a file and carry on from there. Yeah, this is just for like local debugging. I used this like once or twice and then I never used it again. I got lazy. I didn't want to waste time testing out failed transactions. You know, you're sending like hundreds every day, right? So trying to simulate why you failed a transaction and ARB is like, okay, I'm profitable, so let's just focus on deploying to other places. So I didn't really do it. But here, if I wanted to continue from a certain data set, I can. Okay, this is getting the ABI. So this ABI here is for parsing events. So when an event occurs and you get the data, you need to know what's the event and what the data represents. So getting the ABI here is to know how to process the event data. There's two here, and I think we'll run into the reason why I get two here later on. Okay. Okay, we're here already, right? So the reason why there's two ABIs, which is Uniswap V2 and Hermes V1 ABI, is because for some reason their sync event uses uint 256, but Uniswap uses uint 112, and this changes the hash. Yeah, it changes the event signature. So that's why I needed two ABIs here, because they're two different ways of reading the data, right? So that's why. Okay, and then let's see. Okay, here I'm updating the reserves. Price markets is just getting the price of the current token. Yeah, so whatever the token is, it's just token over WETH times ETH price. Yeah, it's the ratio. Just the ratio between the token and the WETH pair, right? So pools have the token pair. We can go through this a bit. Pools are basically a pair with a pool with WETH tokens and with WETH and token A, right? So when you put in A, when you do a swap, you put in A and you take out WETH. And the same is also true the other way around, right? If you are, so in this case, you are selling token A and you're getting back WETH, but you can also like put in WETH and get out token A. And the formula is dictated by xy equals to k, right? So this is x, this is y. Yeah. How do you test your new code? Did you just deploy on the mainnet? Yes. So for very cheap transaction fee chains like Metis, like other chains, like Base or something, you can just test in production. It's fine because it's so cheap to deploy and test tokens, test transactions. But if you're doing it on Ethereum, let's say, then you need to do like simulations and stuff with Foundry and things like that. Yeah, or you can even do it on testnet too, right? I think a lot of people, they start with ETH Sepolia before they try and run on mainnet. But for very cheap chains, you can just deploy and test. Yeah, it's fine. Okay. Here I am just saving, so I'm just storing in JSON the whole data set so that I can play around with it later on. Okay. Okay, this is an interesting thing. Mark reserves as stale. Okay, I guess I can start. I can explain this. So this is how the bot works, right? Okay, just another extra note. Do I have it here? Okay, from here, right? From the factory, I grab all the pairs, and I get the WETH token pairs, and then I group them like this. One thing that I did was I stored the reserves separately. So what do I mean by that? I have this is all a map. This is all a map, right? A map from token A to the object. A map from the token. The key is the token, and the object is the array of Uniswap V2 addresses, Uniswap V2 pairs, the struct, right? But I have a separate array for the reserves. Whoops. Yeah, for the reserves. Why? because when I read them on chain, I can just plop it in. Yeah. And how I know which index, let's say this is 0, 1, 2, which index in this array represents, like for example, this pair. So in the struct, I have an object called, or a field called reserve index. And this reserve index represents this index right here. So if I want to get the reserves, I need to go to the map, find the pair, find the reserve index, then I know, then I can get it from this array, a separate array here. Why I do this is because when I read reserves on chain, I send a pair of addresses and I get back an array of reserves. And then I just bam, put it in here. Now, this is one part. Another part is I have something called a stale reserves. So what is a stale reserve? I think we need to go back. How profitable were you with this bot back in 22? It was my 4th most profitable bot at the time. Yeah. It was good actually. When I ran it the first week, I got like $50 US, which is big as someone who's not living in the US. So it was pretty good. And yeah, it was my 4th most profitable bot up to 2023, I think. Okay. Okay, I think we need to rewind a bit. So the main method I use to update reserves is events. Basically sync events. Right. So when a trade occurs, if you recall that Metis has one block, one transaction, right? So transactions are coming in fast. Here, I use the sync event, meaning that if a transaction has a sync event inside, then I know that someone swapped something. So this sync event will come in like very fast, right? So for example, so let's say this is time, right? And then, so events will come in, bam, bam, and then bam, like that. So when an event comes, I will do the processing. So I will look at the event, I'll see, okay, what is the new reserves for that pool? And when I update it, then I do my calculation. I calculate, okay, are there any arbitrages that I can do? And then if there is, then I send a transaction. Okay, I keep accidentally clicking the button. I send a transaction. Okay, now, what I can do is every time I get an event, I can do all my calculations here. I can do everything, like, okay, all my pairs, I'll check out everything. But let's say I have an array of stale reserves. Or let's say I track, how do I explain this? Right, so what I do is that in my array of reserves, I have another array, a mirror, which I call stale. Now, when it starts, everything is 0, right? But when I receive a sync event for a specific reserve, I set it to 1. Okay, it's just a boolean. You can think of it like that. So why do I do this? Basically, when I do my processing, let's say I have 50 pairs, right? When I'm doing the permutation, which is like testing each arbitrage, if I encounter 2 pools that are stale, I don't do it. Right? Why do you want to process pools that have stale reserves? Because this way you have already processed it beforehand. So this is how this is what is meant by stale reserves. I keep a track of what reserves are updated, and then if I'm comparing the prices in my pool of all of my tokens, if I encounter a stale reserve, I just won't calculate it, because I know there won't be any arbitrages, because it is implied that I have calculated this before. Yeah, so this is what I mean by stale reserves. This is another method that I thought it would help me become faster. Yeah, at the time. Okay. Yep, this is basically it. So this is what is meant when you see stale reserves. So mark reserves as stale, meaning I mark everything as stale, and when I get a new event, I know which one is good, or which one has been updated, and I just look at those pairs. So it saves a lot of repeating. Okay. We'll look at this a bit more later on too. Yeah. Okay, tickers. Tickers are basically every time interval, it will generate a message in the channel. This is a channel, and every 1 second it's going to trigger something. Excuse me. So I usually have a lot of tickers in my bots, like 24 hours, 5 minutes. This is 5 minutes, 1 minute, and 1 second. So we'll see how these are used later on. Okay, so this is the main loop. So this for loop is the main loop, and in this main loop I have a select statement where if I receive a new event, then the code in that is run, right? Let's see. So this is just a stop signal from the parent process, from the parent bot. Okay, this one's interesting. Okay, every 1 minute I update the nonce. Why is that? If you think about it, if you send a transaction, you can increase the nonce, right? Now, reading the nonce takes time. So what I do is I don't want to read when I want to send a transaction. I want to know beforehand so that I can send a transaction as fast as possible. But why am I getting the nonce every 1 minute? So I think I went through this in my thread, in my MEV thread. Metis has a single sequencer, right? So this sequencer is the one that is building the blocks. I want to be fast, right? So one idea is I can spam the sequencer. By spamming the sequencer, I have multiple bots. Bot 1, bot 2, bot 3, and they are in different locations. Let's say this is in US 1, US 2, US 3, right? So I can have different bots, and when there's an arbitrage opportunity, everyone sends the transaction. So whoever is faster will reach the sequencer first, and then that's good. So whoever is faster, the transaction gets mined. Whoever is slower, the sequencer will say nonce too low. Nonce too low meaning that someone has already, another bot has sent the transaction. Right. So this is part one of this piece of code. Okay, part 2 is, okay, there's a bit of an issue here. Let's say, again, I'll draw the time and sync event, right? The event where someone has made a trade on chain. If I get an event, right, I can process the event. And then I can look for arbs, right? Now, what if my competitor sends an event? My competitor arbitrages. So when a competitor arbitrages, there's actually two events. Why? Because the competitor is also doing a buy cheap, sell expensive. So because they are doing this buy cheap, sell expensive, which is the arbitrage, there's going to be two sync events inside one transactions. Because there will be two sync events, if I process this event only, it's going to be wrong. Right, why? Because I'm just looking at the buy, but I missed the sell part of the transaction. So this is one issue that I ran into at the time. If a competitor sends an arbitrage, I get a sync event, but I need to make sure that I include both when I process the event. I can't just include one half, because then I'm working with like incomplete information, and there might be ARBs that actually are not there. Right. So how did I solve this? The way I solved it was I set a time limit, or I set a time range, meaning that if I get an event, I wait for some time. Let's say 1 millisecond. So whenever I get other events in here, I'll accumulate them. I'll update the stale reserves to become like 1, 1, 1. And then here, I do the processing. So now I have some kind of way to make sure that I get all of the data before I do the processing, so that I don't do processing using partial data. So this is one part. Okay, now, but if I do it this way, there will be some cases where I miss some kind of event here, right, which is outside of the 1 millisecond. So what happens is this might cause like ARBs that are not there, right? ARBs that are not supposed to be there or something. Or maybe, actually, maybe this one is wrong, right? Because I don't include this extra one event that's outside the 1 millisecond. So now what happens is, because of this probability of this happening, some bots might be sending transactions for ARBs that do not exist, because they happen to be working with incomplete information. And so this causes the nonce to be way out of whack. Right? How do you even know who is right, who is the correct, who has the oh yeah. So this causes the nonce to go haywire. Not to say haywire, but it's not going to be like super deterministic at any moment that this bot knows what is nonce without having to read or requery the correct nonce at the moment, because of the behavior or potential behavior of all the other bots, right? So how I solve this is I just run as many bots, and I update the nonce every 1 minute. Yeah. Okay. Oh, another thing. Why not I use different addresses? Like this one is using 0x1. This one is using 0x2. This one is using 0x3. Well, I can, but I'll be paying for more failed transactions here. Yeah, I'll be paying for like 3 times the failed transactions, right? So why not? I just use the same address. So everyone uses 0x1, and whoever is late just gets an error, and then that's it. So from the chain perspective, they only select one address sending transactions, but actually off chain, I have multiple bots all using the same address, sharing the nonce, or trying to use the same nonce, sending transactions, and I can be fast without having to like spend 3 times, 4 times the transaction fee of failed arbitrages. So that is why there is every 1 minute I'm reading the nonce. Yeah, and there's more to this, so we'll talk about it later. Yeah, again, more ideas on how to be fast using a single sequencer. I think Arbitrum has this issue as well. When they had like a single sequencer as well, like everyone was connecting to the sequencer, like using like thousands of clients or instances of their bots. Yeah, that's good. Yep. Any questions, just let me know. Yeah. Okay. So yeah, just to give you an idea about the problems and how I tried to approach them back then. Okay, I think we can move on. So every 5 minutes, I get the balance and also report the balance. Calculate mean profit. Okay, every 5 minutes, I calculate the mean profit. This one's interesting. Metis didn't have like fluctuating gas prices at the time, so this is fine. I don't need to like get the current gas price before I send transactions, so I can actually be fast, like just send transactions out. Other than that, I report my balances into InfluxDB. This is just for my monitoring. I think I shared a blurred picture of my Grafana a while back, right? A few days ago. So this is basically that part. Here I have a safety check where if I lose a lot of ETH for some reason, here it's 0.5. So 1 Metis is like $50 now, is it? I don't know. Yeah, but if I lose 0.5, I'll send a transaction and I'll stop. I'll sleep for 24 hours just so that I can check out what's going on. Is there a problem? Usually a big problem is there's an arbitrage that looks legit but actually fails on chain, but my bot doesn't know that. It just tries to arbitrage the thing, but if it fails on chain but it's still there, it's gonna try for like a full hour and I'm gonna drain my whole balance. So that's why I have the safety here, just checking the balance, and if it has dropped significantly or it has been dropping, meaning I'm not profitable, I just pause so that I have time to look into it. Yeah. Okay, this one we're gonna ignore. Why? Here, what it's saying here is every 1 second, I'm evaluating the market, which is like, why? Okay, this is actually near the end of this bot's life cycle. So what happened here is, I think I mentioned that Metis has a single sequencer, but at the time, they wanted to do decentralized sequencing. So decentralized sequencer, meaning there's now multiple people taking turns becoming the sequencer. And what happened at the time was some of them did not provide WebSocket connections, or they did, but it didn't actually emit any events. There was no events being emitted for some reason by these new decentralized sequences. So as a hack or as a bodge, if you would call it, I added this part here where every 1 second I just read the state of the blockchain because they stopped giving events. Yeah, so this is like near the end of the life cycle before I just stop the whole bot for good. Yeah. Okay, I think we'll skip this because this is covered by this part here, which is the actual part where I receive sync events. Yeah. So when I get a sync event, I check. When I get an event in general, I check, okay, is it actually the sync event here? Topic 0 is the event signature, right? And I check it here. If it's not, I just continue. Okay, there's this part here where for every event, it has the block number inside that event. But if the block number is equal to a previous block that I processed, wait, this doesn't make sense. Yeah, this is correct. Okay, if the block number is equal to a previous block, what does this mean? I mentioned that in Metis we have one block equals one transaction, but when a competitor sends a transaction, these two sync events are considered as the same block. Right, because my competitor, they send transactions, and in one transaction there's multiple buys and sells. So there's multiple sync events within one transaction, and so that one transaction is the same block. So if I detect that I processed a block, but when I process again, I'm processing the same block, which means this has occurred. This case here, where the competitor's transaction has multiple sync events, but I only processed half of it. So this is where I track in the code, where I track the case where I did not wait for all the events for that batch, let's say, or block. So I call it a premature calculation, premature calcs. This is what's happening here. Yeah. So again, the problems that I faced at the time. Okay, this one's very interesting. Okay, spin lock. Do any of you know what spin lock is? Okay, we can continue from one of the things that I explained just now, which is this part here. Okay. So let's say I set a time for 1 millisecond, right? So when I receive an event, I wait for 1 millisecond and then I do my processing. Okay, cool. There's many ways you can do this. For example, one way is, let me bring this down lower. So there's many ways to do this. One way is, for example, to sleep. So let's say when I receive an event, I sleep for 1 millisecond. After that, after I sleep, then I do my processing, like here. So this is well and good and all, but in computers, when you do a sleep, the core or the CPU, I'll use different color, the CPU will like ignore you for 1 second. So when you say sleep, okay, you can sleep for 1 millisecond and the CPU does its other job, right? Like tending to other processes in your computer, right? And then when 1 millisecond is up, you're gonna be like, hey, I'm done sleeping. Can you work on me? But there'll be some time before the CPU actually goes to work on you. Yeah, because the CPU is like trying to finish up some other part of the process, and then they go back to you. So even though you're sleeping for 1 millisecond, you're not really, it's gonna be like 1 millisecond plus some time where you had to wait for the CPU to continue on with you, right? So this is sleeping. So what spin lock is, basically, instead of I sleep, I will use a for loop, an infinite for loop, and just repeat an empty loop for 1 millisecond. So that way the CPU never lets go of me. Yeah, the CPU never lets go of me, and we don't run into this issue of the CPU like, hey, please work on me. But the CPU is like, okay, 1 second, I'm just finishing things up and then I'll go back to you, right? So spin locking is just using a for loop and just looping very aggressively during the 1 millisecond period. Okay, this is one thing. Another thing is, so like I mentioned just now, I'll draw the graph again. You have a graph over time. Where I get events. And I wait for 1 millisecond. I said this is 1 millisecond. So again, what I can do is I can wait for all the events and then I do my processing. Let's say processing is this this green square here. One smart thing I can do is every time I receive an event within this 1 millisecond, I do my processing. Right, so let's say a processing takes this long. Every time I receive it, I do this processing. So what happens is if I no longer receive any events, I can continue on with the rest of the function. I can continue on with sending the transaction here. So now I can end specifically at 1 millisecond here, instead of the traditional way, which is events, 1 millisecond, instead of this. See, there's a difference, right? There's a difference between doing the processing within that 1 millisecond and doing the processing after the 1 millisecond. So I achieve this by spin locking. So in the 1 millisecond, I just do a for loop. If I get a sync event, I'll process it. And then once it's done, I can just send the transaction, right? Instead of like this, right? Where I wait for 1 millisecond and then I send a transaction and then I process and then I send a transaction here. So now we can be faster. This is another idea that I had using spin locking. You may run into a situation where the event is like here and your processing is like leaking a bit, but for the most part, it's going to be faster than the second case here. So this is why, or this is what this part of the code is doing, spin lock. Yeah, this is what this part of the code is doing, the spin locking. I learned about spin locking in university, and now I'm able to use it, which is good, I guess. What I explained just now, I don't know if this is still an issue in modern CPUs. I don't know. It's just what I was taught back in university, and so I was like, okay, I can do this way. I can do it a smarter way of doing it instead of just sleeping for 1 millisecond. So this is what this whole block is doing, block of code is doing, right? Yep. So now I usually end on the dot at 1 millisecond, and I can go on with taking sending the transaction. Here, there's an interesting thing here, which is if the length of arbitrages is less than or equal to 1, I don't do an arbitrage. Okay, very, very, very interesting. What does that mean? Okay, let's go into the event. We'll take a look at this one first. Here, I just update the reserves. So I just process the data, and then I update the reserve, and I update the pricing. So when the reserves change, the price of the token changes. So here I just update that, and that's it. Right, for updating the reserves using an event. But, okay, not but. Next is the evaluate markets recursive. Recursive, so this is a recursive function. Let's take a look, or I can explain it, right? Okay, so I think I touched on this briefly, where okay, maybe we'll make a new one. Yeah. So for every new pair or pool, I do this kind of permutation where I try and compare the prices and see if I can buy from one and sell to the other, right? So what happens when there's an arbitrage? When there's arbitrage, I buy from the cheaper one and sell to the more expensive one, right? So this is me buying. I buy from here and then I sell here and I get back the profit, right? So buy cheap, sell expensive. This is cheap. Yeah, and this is expensive. But when that happens, okay, let me draw beakers, right? You can think of it like water in a collection of beakers, right? So this is the price. Let's say everyone is in the same price except there's one that is higher. So higher meaning it has more tokens. More tokens mean it is cheap. It is not rare. I hope that makes sense, but just think of it as like this is cheaper, right? And this is expensive because it's lower. There's less tokens, meaning it's rare. So rare is expensive. So you want to buy from the cheap, sell to the expensive. When you do that, what happens is it's going to be like this, right? It's going to like normalize. It's going to be like, or maybe I do it here. It's going to be like here. And this one is gonna be here. Right, so it's gonna go to a different, it's gonna have the same height because you are normalizing the price. From the expensive pool to the cheap pool, you are normalizing the price. Now the price is the same. But the price of these two with respect to this, with respect to other pools are different. So now you can actually repeat the same process. You can just arbitrage between this and this. So now there's two arbitrages. When even though like it's just one user buying from the one user like selling here, now it becomes cheaper. You can buy here and sell here, but then you can also afterwards you can buy here and sell on another pool because the other pools are untouched. And so what happens is you are doing this process of just normalizing all of the pairs to become the same price, back to the same price. Yeah, so this is the idea of follow-ups. From one arbitrage, it creates an opportunity to arbitrage more. So this is what I call follow-ups. I shared in the Twitter thread about MEV that I was using this to grab these secondary ARBs. My competitors, the top competitors of the chain, they were just doing one ARB. Right, let's say the biggest to the biggest. But they ignored all the smaller ARBs. So what I did is I focused on these smaller ARBs that happened because of the bigger ARBs. So I called them follow-ups. It turns out that the top Arbitrage bot on Avalanche was using this exact same method to essentially conquer the whole chain, to arbitrage the whole chain. Yeah. So you can see that this kind of way of follow-ups lends itself well to recursive functions. Recursive. So if you don't know, recursive means that I have a function. I have a function f where there is a condition where I call f again, right? So it calls itself. So why is this important? Well, I can process, then I can update my reserves, and then I can process again to check out what other ARBs that happen because of the first initial ARB. So here you'll see this in action, right? Here I'm comparing the prices. Here is stale reserves, meaning that if both pairs are stale reserves, I don't calculate anything because I know there's not going to be a new arbitrage there. If there is an opportunity, I add it into a new data. I collect it into a variable, and if there's variable inside, here I do the calculation. This part is all the doing the swap. I calculate the optimal size. This is in my original MEV thread. I get the amount out of the buy, and then I get the amount out of the sell. Buy from the cheap, sell to the expensive. And now I have proceeds from selling from the sell. So the profit is just the size in minus, or the proceeds minus size in. So this is my profit. It's over here. Now, if I find that an opportunity, I log it, right? I store it. And then I look for other opportunities with other pairs. I repeat that. And then, okay. Now, if there is an arbitrage, what I do is I update reserve by ARB, meaning that if this arbitrage were to be successful, I update all of the data, all of the new reserves of the pools after the ARB, and then I calculate everything again. So recursively process everything again to look for more arbitrages. You can do this many times. It will taper out, meaning that the first arbitrages are very profitable because you're arbitraging between very liquid pairs, but the secondary and the third arbitrage is going to be, the profit will be a lot less because it's less liquid. If you recall that I mentioned the sorting thing beforehand, where I sort the pools in order of descending liquidity, right? So your profit is going to be like, first it's going to be high, then it's going to be low, and then here it's like not worth it anymore to run based on the gas price, let's say gas price and gas consumed. Okay, so again, I do this, and I have a argument called depth, like to track how deep am I within the recursive, how deep am I in the recursive process. Yeah. So once everything is done, then I just batch everything, batch all of the ARBs, and I just send them on chain. Yep. So that's basically it. This is the batched arbitrage method, or I call them follow-ups. Yeah. There's many ways you can do this, right? You can do ARBs like just one-to-one. You can do it in a circular fashion. Yeah. It might be a bit more harder to do this with circular, but you can. Just that, okay, you need to be fast too, right? At least in this case. So that's evaluate market recursive. Let's take a 5-minute break. Actually, I'll break for 5 minutes. I'll be right back. Yeah. Okay, I'm back. Let's chill out for a few minutes. Quite the so you can see that there's a lot of thought that goes behind a lot of the implementation. Yeah, which is crazy. Definitely, it was a period of my life that I cherish a lot, because it was the first time, like, oh, I'm in a new industry, like I'm trying to make it. There's a lot of drive and a lot of ideas on how to tackle problems at the time. So very, very interesting part. Yeah. This might not be as technical as a lot of other people who do searching, but even though it's not that technical, you can still go through a lot of the problem solving process and have these like small but very meaningful ideas that can give you the edge. Yeah, I this is my whole strategy, or no, this is my whole way of life in crypto, is these like very out of the box ideas on how to trade or how to do MEV. So if you want to be successful in this, you have to carve out your own space or your own existence with your own ideas and things like that. So hopefully that has been, I'm able to show that a bit so far with all of the ideas and the technical ideas behind it. Hopefully you guys can follow it. It's not like cutting edge or anything, right? It's just like an application of an idea on how to be faster and how to compete with others, or compete or not compete with others. Yeah, things like that. Very fun. Just to tell you a story, and not really a story. I was staying up late, I think, when Pengu airdrop was dropped. I stayed up late just trying to claim. I managed to claim like half, and I had issues claiming the other half. I'm like, oh, fuck it. But this is our lives right now. Just in early morning or late at night, trying to claim like cents on chain. So funny. but I wouldn't trade this life for any other. It's so good. Yeah. Okay, I think I think we can continue, right? I couldn't claim for 2 days. Yeah. I waited for the next day, and I think the price dropped like 50%. I didn't mind it though. It was okay, but I managed to claim a lot because when I do the MEV stuff, I did run some things on Ethereum, and all of them were considered as OG addresses. Yeah, I had like 15 addresses that I used to run bots on Ethereum, and all 15 were like OG addresses. So it was a good chunk for me. Yeah, Pengu. I guess if you held it until now, it pumped, right? So I didn't mind it. So okay, let's continue. I think we're near the end already. Just a few more stuff. Okay, to follow up on the batched arbitrage idea here. So I decided that, okay, I don't want to compete with my competitors or the top people in the chain. So I decided that I'll just focus on the smaller arbs and just focus on getting them. That is why there is this here condition where if the length of the arbitrages that I'm expecting is less than or equal to 1, I assume there's no arbitrage at all, because then all my other competitors will be fighting for it. I don't want that. I want when there's like 2, 3 or more arbitrages, only then I'll send my transaction, and then there's a higher probability of my transaction landing an arbitrage somewhere, you know. And because of the cheap transaction fee, then you can earn like I guess dollars or cents or whatever, and that's fine. There's going to be hundreds of opportunities every day, so that is enough for me to make a living at the time. Yeah, very good. Okay, so now if there are more arbitrages, then I go take opportunities. If you notice this go here, this means that this is spawning another thread and running this in the background because I want to be fast, right? So I'm just like, okay, in the background, do the thing while I continue on with everything else. Let's take a look at this function here, take opportunities. Okay, so again, very simple. So here, the command code here is to simulate a transaction. If you wanted to simulate a transaction, you would use this, something like this. The most important part is setting the no send to true. When you set the no send from the auth, if you set the no send to true, when you call this function, it'll return the transaction, but it doesn't send the transaction. From here, you can use this transaction to grab the data, the call data, which is the data you're sending to the smart contract you're interacting with. There's many ways of doing this as well. Like this is one way. Another way is to just use pack data. I forgot what it is. You have an API. You go API dot pack into interface or something. I can't type. I don't know. It's something like this. Interface. Yeah, something like that. Many ways to do it. What you want is just this. This is the important part. This call message here. So you put in all the information, right? Data. And then you call. Here I use estimate gas. You can also use call, I think. Yeah. Things like that. So this is how you simulate off-chain your transaction. Because I want to be fast, I don't simulate, I just send. And because transaction fees are cheap too, I just send. You know, just YOLO it. So here it is. So I have the arbs that I batched, and then I have this main profit wave follow-up, which is the minimum profit for follow-ups. There's two things here. Let me jump into drawing for a bit. There's actually two minimum profits. There's a normal minimum profit, and then there's a follow-up minimum profit. Why? When I mention that for a set of arbs, I have a profit P, and the number of arbs, the profit of the arbs go down as more arbs, more and more arbs inside the same. More batch arbs, the more there is, the less profit, the less its profit. For the first arb, I use min profit because I want it to be big, but these follow-up arbs, we'll do them in a different color. These follow-up arbs, I only need a small amount of minimum profit. Why? Because for the min profit, it needs to be worth it, right? Because I'm sending a transaction to capture the first few arbs, let's say. But for the follow-ups, it's like might as well, you know? So for arbs that are like might as well do them, since they're there, they can have a smaller amount of profit. Yeah. But both of these need to be greater than the gas price and the gas you are consuming. Yeah, so that's basically it. So that's why there's two different follow-ups, two different minimum profits. There's a big minimum profit where I use to determine if I want to send a transaction, and then there's follow-up minimum profits where if there happens to be follow-up arbitrages after the big one, yeah, it has to be at least this amount to make it worth it. Yeah. So that's why there's this follow-up min profit in the code. Okay. So far so good, nothing else. Some logging. Here, this is the error that I mentioned just now. Nonce too low. So nonce too low is when a different one of my bots have sent the transaction faster. So now the slower bots, they get this error, nonce too low. Yeah, so that's how they know. Okay, another bot sent a faster transaction for ARB. That's it. Okay. Let's take a look at the smart contract for this. So the smart contract is this one. Execute native ARB. Why do I call it native ARB? It's because I'm using a WETH token pairs. So WETH token pairs, WETH is the native token, you could say. Okay, so this is a smart contract I use to execute the arbitrages. I have this struct called arb, which I think you saw just now, where I have all of the information, including from what pair, how much in, how much out, and also there's this bool here. I can explain this later. Okay. I have a struct of vars here. If you are not familiar, if there's too many variables in your contract inside a function, you'll run into an issue called stack too deep. So to not run into a stack too deep issue error, you can store your variables in a struct, and this will not cause a stack too deep error due to too many variables being in the function. Okay, so Metis is quite interesting. Let's see. Let me draw something. On Metis, you have, so you know on Ethereum you have ETH, right? you have ETH, which is your address dot balance, and then you have WETH. WETH has a very distinct address, 0x something, right? On Metis, it's a bit different. On Metis is interesting. On Metis, they have the ETH, or they have the Metis, I guess, which is your native token, again, address.balance. They also have a Metis, which has a contract address. I think it's 0x dead, ... These two are in sync. So you can send Metis as an ERC20 token, or you can send it as ETH or Metis, the native token, and both will be reflected the same on the blockchain. This is something different that they did, right? Yeah, there's two ways of interacting with Metis on chain. And there's also some guy, I don't know who, they went and deployed their own wrap Metis. So this has a different address as well. Yeah. So similarly, you can, same as regular WETH, you can deposit and get back wrap Metis. So now there's like two tokens here. There's like the actual Metis that you can use in pools, like a wrap token, but you also have an actual wrap token. Like an actual wrap token that someone deployed on chain. You know, everyone can deploy a wrap token, right? There's no vulnerabilities or whatever for wrap, for WETH or wrap, whatever. It has been figured out, so anyone can do it. So that's why there is a native token address and also a wrap Metis address. And I can arbitrage between the two. I just need to add a step in the middle, which is either deposit or withdraw. Right? Either I deposit to get from regular Metis to wrap Metis, or I can withdraw to go the other way. So you'll see this step in the smart contract code. Okay. Okay, I have this smart contract called withdrawable. It's just a base smart contract that allows me to withdraw anything I want from the contract. This is just a safety feature. Let's say I have funds stuck in the contract for some reason. I can use a function inside this withdrawable smart contract to withdraw it as the owner. Yeah, this is just, I don't want to have money stuck in a contract that I can't get out, right? So this is just a safety stuff. Okay, this is the function that we saw just now, execute native arb. It takes an array of arbs and has a minimum profit. Okay, what it does is, for every arb that it has, it runs through, it does the calculation using get amount out here. But you can see there's an extra for loop here. What is this? If you look at K is here. K is dividing the native in amount. Native in amount is the amount you're putting in to buy from the cheap pool. So there's actually another loop which goes from 1 to 2, which reduces the size of the native in amount. So what's happening here is that first I get the reserves on chain. When the transaction lands on chain, I get the reserves, and then I calculate, is there an arbitrage? Okay, if there is, it has to be greater than my minimum profit. The amount that I'm putting in plus the minimum profit, right? If it is, then yes, there's an arbitrage, we can grab it. But if there isn't, this code actually tries again, but with half the size. Yeah. So you can imagine that when there's a big price event that occurs, the volatility is going to be big. The price is going to go haywire, up, down. So my competitors, people who are arbitraging and people who are just swapping regularly, there's going to be a lot of people trying to do that. So if my transaction happens to land in a blockchain state where there are arbitrages that only occur if I use the size, half the size, then okay, I'll just grab it. Yeah. This is another thing that I do, like, because gas price is so cheap, I can just do some like blind arbitrage on chain. Yeah, this is called the blind arbitrage, I think. But in this case, I just test out half the size, right? The reason why, so what is the case where a regular arbitrage is not there, but if you try half the amount, there is an arbitrage. It's because of price impact. So so price impact is the bigger size your trade, bigger size, bigger price impact. There's a long reason why, there's a big reason why pools do this. You can imagine, like, there's one article I read by Paradigm. You can imagine there's someone like a market maker, right? A market maker, he has a lot of buys and sells. And if you want to buy and sell, you buy and sell from the market maker. And the market maker is happy to kind of help you be able to buy and sell your token, right? But what if you came in and you said, I want to buy 10 million of this token. If you want to buy 10 million, your market maker is like, what the fuck? Is this guy for real? Does he have information that I don't have? So the market maker is going to be like, okay, I'll sell you at a certain price. This price is actually worse than if you would have bought with like 10,000. Yeah. Let's say if you bought at that. Sorry. Let's say if you bought at 10,000, I'll give you 9,099.99, right? But if you buy at 10 million, the market maker is gonna be like, do you have information that I don't have? I don't wanna risk it, so I'll give you like 8. This is an extreme example, but yeah, I'll give you like 8. So this is price impact. I should do this in orange actually. I'll give you like 8. Right, so you can see the difference, right? Extreme example, but I'm just giving you an example of price impact. This is the reason why you have price impact in blockchain automated market makers. I think it's called fading. Yeah, fading. The bigger your size, the higher the price impact. So because of this price impact, it might render some arbitrage null. Because of price impact, you're going to lose your profit in the form of price impact. But if you halve the size, there may be a case where an arbitrage is possible. So this is why this code here is just trying like, okay, I'll try half and see if there's an arbitrage. And it does work. I have noticed that I do get arbitrages that are not using the in amount that I set originally. So I don't know how much this has earned me, but this idea has earned me money. Yeah, basically is what I'm saying. So very amusing. Yeah. So this just this part. That's it. Yep, that's this part. Okay, if there is an opportunity present, I pack everything into a bytes data. And then I call this a swap function. So the swap function, if there is data, it will try and call the callback function on your smart contract. Okay, this part is transferring the opportunities, transferring the profits, sorry, back to I send it back to the executor address, the EOA address here. Let's see. Okay, this one's interesting. So now, when I do this swap here, and I have data, the pair tries to call a specific function on my smart contract. What function? There can be multiple. So here you can see I have a list of functions which includes the original like OG Uniswap V2 call, but all of them goes into this another function called base hook, which is like the same function that actually does the thing that the selling part, right? Yeah. Which completes the swap. So there's actually a better way of doing this nowadays, and that is to utilize the fallback function. So if you recall, the fallback function is when the data does not match any other function inside your contract. It will go into fallback. So what you can do is actually you can use this to say that, okay, I can set it so that if a contract is trying to call a specific function on me and I don't have that function signature, I assume it is a callback function, Uniswap V2 callback function. So I can just process the data, pack it, and then I call my function here. Yeah, so this is the latest way of doing it. A smarter way, which means that you don't have to have like tens or even 20 functions to cover all the possible callbacks that the protocols that your arbing has. Yeah. Okay, so this is the latest way of doing it, but this is old, so we go here. Let's look at this base hook. So this is the actual meat of the callback, right? Let me drink some water for 1 second. Okay, so in this actual hook, I get back the data. So here I decode the data. So whatever I packed just now, which is here, right? I unpack it there. Here. So I just get back all the data. Okay, let's see. There's a require here, which is that to make sure that I'm not being called by some kind of exploiter or hacker. So I commented it. So I guess it doesn't matter. My contract doesn't have funds, doesn't hold funds compared to like other arbitrage bots. So I specifically or exclusively use flash swaps. But if your contract does have funds, you need something like this. You need to take care so that your contract isn't like attacked by a malicious token that kind of is able to drain your funds and stuff like that. Okay, this one is the part that I mentioned where if I am doing an arbitrage that involves a native token pair and a wrap token pair, this is the additional step. So if my sell to, the one that I'm selling to is wrap Metis, I withdraw. Okay, this one is a bit confusing, but in the flash swap example, I grab the money that I'm supposed to get when I sell, and then I use that to buy from the cheaper pool. Yeah, it's a bit different. So maybe I can draw it out, right? This might be confusing. Right? You see the sell to is wrap Metis, but I'm withdrawing. What's going on here? Basically, in flash swaps, you have the cheaper pool and the expensive pool, right? So again, cheaper is more tokens. More tokens is less rare. Less rare means it's cheap. So what happens here is that in flash swaps, I grab the money I'm supposed to earn from selling first. You recall that the callback gives you the money first, and then finally at the last step they check whether you actually did it properly or not. I grab the money from the sell and I buy. I use that money to buy here on the cheaper pool, and the cheaper pool I ask it to send the proceeds to the expensive pool, right? So from when you look at it from your perspective, you're just buying from cheap, selling expensive, which makes sense. In the smart contract, I borrow the money from the expensive, I use it to buy from the cheap, and then I complete the swap. So that's why when you see something like is sell to is wrap Metis, I withdraw because I want to use the money to buy from the cheaper pool. So that's why this is here. But again, this is the intermediate step if I'm interacting between two tokens that are different. So if my buy from is wrap Metis, I deposit and then transfer. Right. Okay, this one is to complete the swap. This is the buy from the cheaper pair. And I ask it to send to the sell to pair. And that's it. Yeah. Once that's done, I repeat. I repeat this whole loop. I repeat for all the other arbitrages that exist. And then lastly, I send all of the profits to the executing address, the executor. And that's it. So now I get money in, I pay the transaction fee in Metis, I get back Metis, and so you can see my balance goes up gradually. My balance goes up like that. Yeah, and then maybe there's some spikes and things like that. So this is what my balance curve looks like when I run the bot. Okay. That's all the smart contract. That's done. This is actually quite simpler than my other contracts, but it's very good. Yep. Again, when you do the calculation for get amount out, you need to remember the fee, or you need to know what the fee is, because this fee, if you set it wrongly, if you set it too low, there's going to be an issue because the pool expects a higher fee. If you set it too big, you're going to miss out on profits that are supposed to be yours. But why can you set it bigger? It's because the pool itself only cares if you send less than the amount they're supposed to. But if you send more, they're like, cool, I'll just take it. So here, this line specifically, balance, as long as the balance adjusted is greater than what they have right now. So if it's more, it's fine. But if it's less, then okay, this is gonna revert. So that's just one thing. Okay, smart contract done. I think that's it basically. We'll go back to here. Again, I do some setup here. This is to prepare for the next transaction that I'll send. I do some reporting here. I do some printing here. Yeah, I write to my database, and that's it. That's done. So, very nostalgic. This is basically it. Yeah, we're done. What is this, like 2 hours? That's good. Yeah. So this is my first ever bot that I ran on Metis. When I first started, I remember like developing this for 1 week, sorry. And then I gradually improved it. It was so crazy too. Like, I think if I can calculate the amount I spent in transaction fees versus my profits, I would have one of the most lowest transaction fee per profit, I think. I guess, how do I write it? My profit, the ratio between my profit. Oops, again. Let's see. The ratio between my profit to transaction fee is very high. Yeah, because of things that I do here. And then, yeah, that's basically it. I was also running using like AWS. I was running like T2.micro when I started, just to get the free credits that you get, just to use the free credits that you get. So crazy. So we actually like started from the bottom and now we're here. I'm not kidding. I was even using T2 micro. I think at the time there's already T3 micro, but I was using T2 micro to get the free credit, which is crazy. Yeah. So, okay, I think that's it. Basically, that's the whole code base. Yeah, like a good year of my life in that, like doing a lot of stuff, a lot of testing. Any more questions? Yeah, just send me on Twitter too. Any questions? It's not, the code's not supposed to run today. It's just an artifact of a previous an artifact of a specific time. Yeah, but I felt like, okay, the end of 2024, I just want to send that out. Yeah. Any questions? If no, then I think that's it. I think we'll call it. Yeah, this is actually a quite a good session, and I was able to kind of articulate a lot of stuff, some of the ideas that I had at the time. Yeah. Can I share? Are you playing around with AI agents at the moment? No. If you're asking if you want to invest in my AI agent, I don't have any. So sorry to say. But yeah, I do understand the trend going on at the moment, right? With AI agents. So funny. But no, not at the moment. Not an AI person. Actually, I don't have like formal education about machine learning and AI. So I don't think I'll take a look into it. Yeah, I just want to chill with what I'm doing at the moment. A lot of stuff to do right now, so I guess it's fine. There's the token called Mira, right? How is it doing now? Can I search for it? Yeah. What are you doing at the moment? Right now, I'm doing MEV with liquidations. So liquidations is a whole nother beast that has a lot of stuff with it. Also, yeah, I'm doing some other stuff as well on the side. Yeah, I don't think I want to go public on that one. So just still busy doing stuff. Yeah. Oh, look at that. Oh, it's stabilized actually. What is this? 8.8 million? That's not bad. So the guy has like 4 million, is it? The Mira guy has like half of the supply, so he has like 4 million still, which is good. I read he sold a good amount. I was hoping he'd not hold for too long. I see. That's fine, I guess. I didn't see that he sold, but I mean that's fine. I guess he didn't sell everything. I did read that this whole thing is done by like a few traders who are behind Peanut and other tokens. Like it's so crazy, right? This guy has like, these traders have like the best ideas, I guess, you know. So they kickstarted this trend of public fundraising and sending half of the supply to the guy, right? Hilarious, but yeah. I read he didn't want to dump on people. Yeah. Some people were like, yo, these crypto people are using your popularity, or just dump on them, right? But I guess he's good. Yeah. I guess he's fine, right? If he sold a small amount, then that's fine, I guess. So it was a cabal thing. Yeah, I think a lot of people noticed that it was a cabal thing. It was something that the people behind Peanut and stuff were behind, you know. But it's a good idea, right? It's a good idea of, let me make a pool. So instead of just collecting donations normally, let me make a token, put it inside a pool, send half of the supply to the donation receiver, and now I get what, 1 million out of that. Crazy. But I guess it's these kinds of ideas that kind of separate the good from the best, you know. Not to say that this is the right thing to do, but you know, it's just the game that we play. But very, very good, I guess. Kudos, I guess, to the cabal. On a different note, is doing MEV still very profitable in 2024, moving into 25? Okay. What I notice is that the competitors are not increasing, at least on other chains. If you look at Ethereum, there's always new people going to Ethereum. If you look at Flashbot's Discord, in the newcomers channel, there's a lot of new people asking questions. But okay, if you want to compare from 2022 to now, not really. It's going to be very hard. Like only top 1% can make money. Most, if not everyone who failed, like is able to land 1 or 2 transactions on chain and then just got dominated by competitors, right? You need very deep understanding on DeFi, like some kind of token from in buttfuck nowhere is like has some kind of opportunity. Yeah, you need to be able to see that. It's profitable, yes, but it's very hard. Yeah. So if you are not like very good in coding, probably better to find in a better niche to make some money, I guess. Yes. A big MEV searcher once said this, is that the amount of time you put into MEV versus the amount of time you put into MEV versus what you earn is very small compared to like if you spent the time building something and then raising money from VC or angel investors or whatever. Yeah. It's definitely a lifestyle. Yeah, what drives to stay in this niche is definitely a lifestyle. Like I work for myself. I do everything on my own time. I don't have investors. I do have to like be ready to put out any fires, right? But I'm earning money for myself and I don't have to deal with other people. And yeah, and I also am not responsible for like other people's money, which is also quite important, right? If you're building a protocol, you're like in charge of, or at least you are looking at holding millions of other people's tokens in TVL. So it's going to be stressful. Right now, I don't have the stress. I just use my own money. I earn a good chunk using that, and I'm fine with that. I'm content with it. And yeah, so it's a lifestyle, definitely. I tried working with some people, but when I think about it, I don't want to like give up my freedom of doing what I want to do. Yeah, so that's good. Yeah, I had a talk in ETHKL like 2 years ago, last year, sorry. That talk was good. Maybe a bit technical. I think this stream is, you can follow this stream more easily than the discussions we had in ETHKL, because of it was looking at the space in general, right? Do you trade as well? I do have a bot that does automated trading. It's a specific strategy that I'm still running. I've been running since July, and it's still profitable, which is like crazy. Someday I will reveal the strategy. Someday, because again, it's one of those things where it's just a small idea specific to blockchain, but it works and it's so crazy, and I can't but not reveal it someday.
but the question is when. So you'll find out, I guess. But I did do some Solana trading. it didn't go as well. It's very hard unless you're in the right groups with the right alpha, and you have strong hands. Then yeah, you can do a lot of stuff. But other than that, Solana trading wasn't profitable for me. I do other trading on other chains. Yeah. Do you typically just do all of this alone, brainstorming, execution? Yes, I do it alone. So one thing about doing it alone is that if you're doing it in a team, you need to go for opportunities that are bigger. But going for opportunities that are bigger, there will be a lot more competitors, and the competitors will be always trying to one up you. They're trying to beat you. So you need to catch up to them. You need to overcome them. So if you're doing it in a team, it's going to be big opportunities, but also like you're going to work in shifts, like 18, not to say 18-hour shifts, but like definitely shifts of like 6-7 hours of constant monitoring and updating and analyzing what competitors are doing. And then you rotate between your team members. Only then it's like worth it for you as a team that's earning a bigger chunk because you're dividing it amongst yourselves. But since I'm doing this by myself, I can focus on opportunities that are very small, very rare. Let's say something that only happens when there's a big event, you know? So I don't have to be on my PC 24/7. I can decide to, let's say, leave something first. For example, I've been having some node issues where my node is restarting by itself. So okay, well, what's going on here? But I haven't had the time to look into it. But it's fine. It's not like my top earner. It's just another part of a strategy in my whole portfolio. It's just a part of my portfolio. So it's less damaging. It's not like my number one golden geese, right? So I can just say, okay, I'll leave it for now and things like that. So that's the freedom that I have as a solo searcher. What's your general framework to formulate ideal strategies? I always start with doing it first. Whatever I do, I start with doing it first, the basic way. Only then I know how to like improve it afterwards. So, and this is for good reason, is because you need the data to be able to formulate your ideas and strategies. In order to get the data, you actually need to do it. You actually need to do the thing regardless. Yeah. So you need to do the thing. You need to try executing on chain and see how you fare versus your competitors. Once you know that, only you are able to think, okay, maybe I'll go this way, maybe I'll go that way. So that's important. What I do is I just do it at first, and then I figure out the special, if I need something special to continue on. Yeah, I think libEVM, even if you don't know, libEVM used to be a searcher as well, and he had a talk in ETHKL as well, like beforehand, and he was like, just do it. Don't think about it, just do it. And so I took that as guidance, and now I also just do it. If there's something, I build upon that. Yeah. So very good. Very grateful to Lib as well. Yeah. I like the idea of living that lifestyle you're living, but probably not big brain enough to do all of this. Haha. Yeah, actually, I'm so fortunate. Why? Because my old job, I already knew programming. I already knew how to use AWS, how to run servers and things like that. So I had all of the prior knowledge to do all of this beforehand. I just had to learn, but I did spend some time learning. Like I remember like having work the next day, but I stayed up until like 12 a.m. doing like Ethernaut. If you don't know, Ethernaut is like a game where if you solve it, you learn deeper about the Ethereum virtual machine. So I got up until like 20 something. Yeah. There's also videos online. Let's see. Yeah, Smart Contract Programmer
I'm gonna show you how to
has videos on Ethernaut. Yeah, I spent like some time learning this, learning regular Solidity programming, Go, and then I spent a week building this bot specifically, this Metis bot here, and then I improved it over time and did a lot of studies. I was at my hometown when I built this bot, which is crazy. Yeah, I remember it fondly, like being in my hometown, just coding away. That was the first week where I decided I wanted to quit my job and pursue this. I gave myself 6 months, and also I was fortunate enough to earn some money in the bull run. Like before 2022, there's a period of bull run, right? And I earned a good chunk of money to be able to like give myself 6 months to do this MEV thing full time. Hi, hey Rainbow, what's up? Yeah, we just finished going through the code. A lot of ideas. You can check out the archive. Yeah, good to see you again. Yeah, thanks for the questions. It's really great. Yeah, happy to chat with you guys like this. What would you recommend doing to learn EVM well, and how much does it help? Ethernaut helps a lot. At first you learn the normal way. You can go for like something like Patrick Collins. Solidity blockchain full course. This one. Solidity blockchain development smart contracts. You can go through everything here, and then you can do something like Ethernaut. So here, this teaches you normal EVM development. Ethernaut teaches you how to go deep. And by going deep, you can do MEV stuff well. Yeah. Yeah, I would recommend this. I would recommend that and Ethernaut. Very important because like you want to go through. If you want to go through the whole specification at once, it's going to be, oh, what the hell? Like, do I want to read this? Crazy, right? But Ethernaut gives you the context where you can use the knowledge, and you can, when you have a problem you don't want to solve, you go here, and you go like, okay, yeah, this is how variables, data is stored inside contracts, right? And then you can go, oh, okay, that's good. So yep, that's what I recommend. Recently, I went through this. Why? I'm doing some. I'll give you one case. When we do liquidations, we use a thing called price oracles, right? So price oracles, they report on the real life price of a certain asset like ETH or BTC, right? And these price oracles, what they do is they report on the price. So you can see there's a transaction going in. Inside the transaction, they have the data. Like for example, ETH is now $3,000, right? Now I want to know where these TXs are being sent to who, right? There were some price oracles that have this data private. Private meaning that it's stored inside the contract, but you can't read it normally, which is like annoying, right? So what I had to do was, this price oracle, based on the code, they use a map of, let's say, asset, the address of the asset to the address of the aggregator. So aggregator is the actual contract which this transaction is being sent to. Or maybe I'll do it like this. Yeah. So this map here stores this thing, and the combination of this and the order in which it appears in the code determines where specifically this data is stored. So I had to go to here and I had to go through like, where is it? This one, I think. Is it this one? Yeah, something like that. Yeah, I have to look at, okay, based on that, the data is stored specifically here. And only then I knew, okay, how do I get the data? Even though it's private, I can still get the data. I just need to find where the location is inside the contract. Are you deploying any strategies with Hyperliquid? No. Don't remind me of Hyperliquid. It makes me shed a tear in my eye when I think about the generational wealth I lost by not farming Hyperliquid. Yeah, it's a shame, but no, I'm not deploying anything with Hyperliquid. Unfortunately, I guess. Oh, I saw this one tweet actually, which is so interesting. I think I retweeted it. Let's see. Which is crazy. Yeah, apparently, yeah, Hyperliquid has some kind of, or maybe Per, right? Per has some kind of automated limit order book. Yeah, and people were scalping it, which is crazy. Yeah, I know I've heard of some people who built a copy trading bot on Hyperliquid. There's also this thing here on Hyperliquid. I think this is manual. This is automated, but yeah, I didn't play Hyperliquid. I don't really do like spot trading and stuff like that. I don't have a lot of money. So if you want me to go spot, Also, I am personally not a fan of leverage. Here, I'll share it in the chat. Yeah, I'm not a fan of leverage. So it's just a personal principle. But yeah, that's the main reason why I wasn't on Hyperliquid. And so I missed like $1 million. Yeah. I have met a few people who did farm Hyperliquid. I tried asking them how much did they put in, but they said it was a personal question, too personal. They didn't want to share. I just wanted to know what is the ratio between the amount they put in versus the points they got, right? Because I imagine that has some kind of reasoning, some kind of correlation. Like the more you have deposited and use Hyperliquid, the more points you get. Yeah, and also the person that I met did some like correlation between how to farm points better. Like some trades, I think they found out that if you lost on the trade, Hyperliquid will compensate you with points, which is interesting, right? Which is like, okay, so why not? In order to farm points, I intentionally take losing trades to be compensated with points that are now very expensive because people believe in Hyperliquid. So that was one thing that I met someone doing. How does Hyperliquid build blocks? Is there an MEV at all, or will be? I have no idea. I haven't touched Hyperliquid, the app, also the chain. I don't know. So I have not heard of people doing that. Probably they are very secretive right now because they are likely printing like millions with the knowledge and expertise of doing MEV on Hyperliquid or HyperX. I'm not familiar with the chain name. Yeah, but that's how it's going. Yeah. This thread is interesting, or this tweet is interesting. They have an arch nemesis, which is like romantic, I guess. Like, we're fighting on chain. I have my rival. This is an anime storyline. We're trying to beat each other, but in the process, both of us become greater because of the other person, which is nice. I don't have arch nemesis on chain. Maybe I do. I know one person who has the address of like 0x666. Basically, sorry. Basically, I'm fighting the demon. I'm fighting the devil. This guy, I guess I can consider him my arch nemesis. He has the address of 0x666. Something. He's a very... He has deployed in a lot of places. I see him everywhere. Yeah. So technically I'm like fighting with the devil at the moment. But he's not that competitive. Like on most chains, he's not the top guy there. But yes, this is the only address that I remember that is my arch nemesis. Yeah. How many hours do you spend on screen daily? Good question. I spend like maybe 8 hours probably. Let's see. Yeah, probably like 8 hours, 9 hours. There are days where I go like 12 hours and stuff like that when I'm really building on something. But yeah, I do spend a lot of time on screen, and I don't wear glasses. And I haven't needed glasses since forever. So I don't know, my eyes are like, I don't know if it's the same for you guys, but yeah, I've been using computers since I was little for a long time, in long stretches of hours, and up till now I don't need glasses and things like that. So I guess that's good. Yeah, it's a blessing. Definitely it's a blessing. Yeah. But yes, I do use computers as much. I don't know if you guys saw, my current setup is like 4 monitors. Let me see if I can bring up that tweet that I had. But basically my setup right now is 4 monitors. I don't know, Twitter search is kind of bugging at the moment, so okay, I see it. This is my setup at the moment. Different location, but yeah, this is my setup at the moment. Yeah, 4 monitors. Yeah, it might seem excessive, but the secret is that you need to have consistent. You need to be consistent in where you have stuff, in where you hold, in where what you use in the different monitors. Let's see. I want to make this bigger actually. Can I? Okay, yeah. So here's, I think I shared this on Twitter a few times. Here's what I use. This part is for Telegram. Maybe I'll use a different color. This part is for Telegram. This one is for messaging, Telegram and stuff. This part is for Spotify. Spotify or either YouTube if I'm playing music. This part is either my main web browser. So I say Chrome. Here I have a lot of my monitoring like Grafana, YouTube, Docs. Right. I'll use a different color. Docs. Okay, here, this is my VS Code. So I'll have VS Code. If I'm watching a video like intently, I'll watch it in the middle. Top right is my Photon and also spreadsheets. I'll write Excel. And then on the bottom right is my terminal to access my servers and stuff. So by having consistent places where you use apps, you actually save all the clicking that you do if you have only one monitor, right? Because you're, instead of clicking and alt tabbing, you're moving to different spaces, and you know that you have the apps there, so you don't spend time thinking, oh, where's my Spotify, where's my terminal? And only then it's worth it for you to have a setup like this or like multiple monitors. If you're trading, then yeah, you would have all the charts here and stuff like that. Definitely not the case for me. Does it get a bit tiresome lonely doing this all alone? Actually, I actually had a period of burnout earlier this year. So what is it? So 2022 to 2023 was very good. However, the end of 2023, like near the end, I got burned out. I was like, I can't deploy my 20th arbitrage bot, my 6th liquidation bot. I got so tired. So here I took a break, I think. And then it was so hard for me to get back in. Here I was doing, if you knew, here I was doing like the Telegram stuff. So the Telegram bots, also the friend tech stuff. Yeah, I was a big user of friend tech. I got a good chunk of from the airdrop, which is good. I did the Telegram bot stuff, some trading stuff. But actual MEV, like this is the part where everything breaks down. What I mean by that is that, like I mentioned just now, like I mentioned just now, Metis went from a single sequencer to a decentralized sequencer. So I had to update it like a lot. I had to update a lot of things, so I didn't do that. Some of my liquidation bots, they were using Uniswap V2, but the most liquid protocol on chain changed to Uniswap V3. This was when Uniswap V3 was, the license for Uniswap V3 went public. Right, I forgot when was this, but there was a time where Uniswap V3, the license was public. So everyone can deploy Uniswap V3 forks at the time. There is a competitor to Uniswap V3 which has the same methodology with Uniswap V3, but it's slightly different. So I guess that's fine. But it's called Algebra. So Algebra is another like Uniswap V3 like protocol that I guess basically was a workaround to the license that Uniswap V3 has. You can call it a workaround. You can call it just using the same tick math method, right? The ticks method, right? But Algebra was one of them, right? And so my liquidation bots was using Uniswap V2, but then all the liquidity went to Uniswap V3. So now I had to update to Uniswap V3. So that's a lot more work, and I was like, fuck it. And so everything died for me during this period of 2023. And then other stuff happened. So basically this part was like, I don't know, my lowest, you would say, in terms of profit, and also in terms of motivation to code, like really. But then I think in my tweet I had like in September, I was like, okay, I want to restart my journey. And so in September I did a lot of stuff. I did a lot of stuff like routing, like stuff. Like for example, you know how when you liquidate, when you're doing liquidations, people can borrow. Sorry, not borrow. People can deposit one kind of token. Let's say they deposit ETH, and then they can borrow another token like wrap BTC, for example. Now, a liquidation market can have a lot of markets. Like they can have ETH, they can have Chainlink, DAI, USDC, USDT. They can have up to like 12 or more, like, right? So now, a lot of users will have their largest deposit and their largest borrow can be any combination of these 12. It can be like ETH to BTC, it can be like ETH to DAI. So now, you can think of all the possible routes that you need to liquidate. It's quite a lot, right? So like there's 12. So like, I don't know how to draw this, but you can imagine like, okay, there's 12 tokens. There's 12, I guess, factorial combinations of tokens. So now when you do your liquidation, if you are not using capital, you need to use swaps, right? Flash swaps. So now there's like a lot of different routes that you need to figure out. for every combination of token. Like for example, you want to do like ETH to RepBTC, then this is quite this is a simple example because there's already an ETH RepBTC pool, right? But if this is like, I don't know, DAI to RepBTC, then you have to go through DAI ETH RepBTC. So this route has its own price impact calculation depending on the liquidity. So now I need to know, okay, I need to know what is the optimal size of every route that exists in all the possible liquidation routes that I need to cover for every kind of user that has, you know, different deposits and different borrows. So in September, I built something that can do this, and I just recently improved it so that it's better able to figure out the optimal sizing. Yeah. So in September I did that, and then only now I'm able to reap the rewards because liquidation is so rare. It's only when there's like big price events is when liquidations happen, right? And so I have this period of like weeks of nothing, and then only then I get opportunities. So that's just how it is. That's just how it goes. But on September and October, I really cooked. And I think that kind of sparked me and got me out of the burnout that I went through in 2023. So yeah, that's some lore for you. Yeah. So yeah, we really went down and went back up again. Do you find it difficult to concentrate when switching between trading and coding? Since trading appears to give quick profits, it can be tempting to focus on that instead of MEV development. Okay, I can't. Yeah, this is something that I went through. One difficulty that I went through. Yeah, you're right. What if I spend my time trading instead of doing MEV? But for me, it's very simple. I'm not a good trader. I'm not as good as a trader as I am as good as an MEV searcher. So it is actually better for me to spend my time doing MEV and reaping the rewards later compared to trading, because I don't have good trading. But I do understand that if you are equally good at trading and MEV, you're thinking about how to spend your time. So yeah. I don't find it difficult, but yeah, I do understand if people do find it difficult. You know, I mean, everyone understands that it just takes like one trade for you to make $1 million, right? On Solana, on Pump Fund. So I think everyone goes through the same thoughts, right? Like, what if I just focus on trading instead of whatever else? But yeah. So I just focus on MEV right now. Even within my MEV stuff, I need to think about, do I want to increase my competition here, or do I want to deploy somewhere else and expand my profits that way? So that's also another thing that you think about when you do like MEV stuff. Yeah. What would you suggest for getting better at transaction ordering, route optimization, and analyzing markets? I don't have a good I'm not that good of a quantitative guy to answer this. Let's see. I guess you need to be familiar with the maths, and you need to be familiar with the common algorithms. Yeah, to just be familiar with it, and when you want to implement it, then you can use like ChatGPT or whatever. I mean, sure, you can do it yourself, but you know, ChatGPT is gonna help you do that. So I can give you an example. This, when you think about this situation here, where you have like 12 different tokens, and this lending protocol supports 12 tokens, and then you're gonna have a lot of routes, right? So what happens is you're gonna have like, so this is a pair. Let's say this is a WETH. Sorry, this is a token. So this is ETH, for example. And then you can go through a pool, let's say ETH USDC to end up in USDC, right? So now, and then there's going to be a lot of other pairs like ETH to wrap BTC, USDC to wrap BTC, right? So this is a common problem called the nodes and edges. Right. So nodes and edges is a problem that has been figured out. When I say figured out, I mean that people have studied this extensively, and there are two most common methods in the industry to do this, right? You have your for example, node traversal. If let's say you want to find a route where the price impact is minimal, like the biggest route you can have with the minimal price impact, you want to look at liquidity, right? So now you can test out like, okay, how is this okay? Maybe a different route is okay. So you're going to have a lot of routes. So when you have a lot of routes, you need to do node traversal, and the top two is, or you can do like depth first search or breadth first search. Yeah, things like that. Dijkstra's algorithm. Yeah, that's correct. What is it? Dijkstra's algorithm, or what, A star or something. So if you understand this, then you can go through this problem here, use it and apply to this problem. Yeah. So basically so in this instance, what I did is is either depth first search or breadth first search to find all possible routes. Yeah, and then I do my stuff. Yeah, you can do lots of stuff with this. Yeah, so triangular arbitrage, whatever. Yeah, everything is here. So that's pretty much it. So to understand everything, I think very likely that the problem that you're dealing with has been figured out in one way or the other. So just know what algorithms are out there. You can ask ChatGPT and stuff like that. I already knew about these algorithms, but I've never implemented them. But when I needed to, then I can just use ChatGPT or whatever. So this is one way of route optimization. I think that this is already common knowledge, right? Because we have all these aggregators and stuff like that. They have to do this to give you the best possible price. Analyzing markets is another thing. That one I don't know. There's one guy on who also used to be an MEV searcher. I forgot the name. Togar. He once told a story where when he looked at the chart, he knew it was arbitrageable. Like he knew from just looking at the chart, you can arbitrage this token. Yeah, probably. Yeah. So that's from his, I guess, background in banking, I think. So I don't know. It can be an intuitive thing if you want to analyze the markets. It can be a quantitative thing where you're actually getting data. So a lot of ways you can do it. Oh, sorry, I think you guys couldn't see that. Okay. Yep. So a lot of different stuff that you can do in crypto. Yeah. Just model the problem, look at what solution is there, and then just go from there. But yeah, I guess this is like just one part of the equation, right? The other part is actually building, actually running nodes and things like that. When I did MEV back then, like 2022, 2023, I didn't even modify even a single node code, and I was able to make money. Like Metis, that you don't need a node. Let's see, Metis has a node. For layer 2s, it's called the replica node, I believe. I'll use a different color. It's called a replica node for layer 2s that are like Optimism, but it's slower. It's like 0.5 seconds slower. In fact, Let me try and find it on GitHub. Right, this is the GitHub where to run a Metis replica node. Replica nodes are slower by half a second. In fact, I can find it in issues. Let's see. Maybe just slow. No. Okay, it might be in here somewhere, but yeah, it's slower. So for Metis, I didn't have to run nodes. I just connected to the sequencer, the single sequencer that they had. After that, I ran other blockchains that did not need any special modification in the node. So I wasn't doing any node stuff. Only now I'm doing some node stuff. Yeah. So some blockchains, they don't readily provide you the pending transaction pool. Like on Ethereum, you can just get what are the pending subscribe to pending transactions. So when a pending transaction occurs, you get it immediately, right? But for some blockchains, they don't. And some blockchains, they like are in the background. So you have to add like additional code in the node software to be able to grab like pending transactions and stuff. I did some speed improvements, you know, like for example, like some nodes, they have code where they do a HTTP call to get some data, right? But this data might be different for different blockchains, right? So blockchain A and blockchain B might have different data, which is why they're doing this. But if you know that the node is for blockchain A, you can just skip this. You don't need this, right? You can just, okay, this is the data. Yeah, so you save one HTTP call, but that one HTTP call can be like 1 millisecond, and that 1 millisecond saved can be the difference between you being faster than your competitor to back run the Oracle update, right? Yeah, back run the Oracle update. You have an Oracle update, you want to be smack that behind. If you're not familiar, on Block Explorer, this transaction is earlier than this transaction. When I first started, I thought that, you know, when you go on Etherscan, right? I thought that the first transaction is the transaction that paid the highest fee. But no, that's not the case. It's actually the last one. This one. These are the transactions that either that bribed the validator or paid huge amounts of gas price, a higher amount of gas price to be able to execute first before the ones afterwards. So if the Oracle update was here, the transaction that wins the liquidation is here. Yeah, it's just one before. Yeah, so that's it. Yeah, so this is one example of saving time by editing node software. There's another way of doing it. Is basically like, you know, your blockchain has a specification, right? Right. Like this is the specification for this blockchain. Like, okay, how do nodes interact with each other and stuff like that. Many searchers, what they do is they write their own special implementation of the specification, and they remove all the guardrails. If you remove all the guardrails, you are faster, and maybe you don't do a lot of stuff that's not needed by your bot. So you do like the bare minimum, which makes you faster, which means you can execute faster and send transactions faster and things like that. So a minimal version of the bot. Yeah. So this is like more advanced stuff. I haven't done this yet. I don't know if I will ever do this. You know, you have to understand, like, I guess the most popular or the most well-known library or the most used library is libp2p. which is the library for communication between peer-to-peer. I believe this is it. Yeah, so if you want to be able to do something like this, you need to have good understanding of libp2p. So yeah, this is basically it. So that's it. Like note, this is one example of how to save time in nodes. You know, like a lot of like blockchain frameworks, they do this because they want to let you make your own chain. Yeah, but then some pieces of data, if you already know what's your chain, you can just skip it. Yep. So that's my journey so far. Yeah, so very fulfilling. I am still growing. Right now I'm working on some stuff. There isn't like anything like that I'm looking forward to at the moment, like something big that I'm looking forward to. But I also have a lot of ideas stored that if I get bored one day, I can just, okay, let's do this now. And it's a different kind of MEV. It's a different kind of beast, different profit curve, different maybe capital requirements, whatever. So that's something that I can look forward to in the future. Yeah. Okay. Damn, we've been talking for like 3 hours. That's crazy. Yeah, but thanks a lot for the questions. Really good questions, and I'm able to talk a lot about it. So hopefully you guys got a lot out of this stream too. I guess we're just chilling at the moment, but probably like 15 minutes. I'll call it. If there's no more questions, I think we can end the stream. Yeah. So we went through a lot of stuff. It's good. Yep. Yeah. You can still make it in MEV, I think. Nowadays, it's just a bit harder. If you have special knowledge, that's the most important thing. Yeah. Alpha. If you have alpha, that's important. I'll think about trying to export this. Maybe I can. Yeah. I'll export this and then we can people can refer to it later on alongside this video. Yep, very good. Any other questions? What time is it? Yeah, probably time for lunch for me. So I don't know. I saw a tweet last night showing about pizza. Now I want pizza. But that remains to be seen whether I'm actually in the mood or not. Yeah. Anything else? I'm just checking my bots at the moment. Oh, okay. Yeah, okay. Okay. If nothing else, I think I'll call it. Yep. So thanks a lot for hanging out. Thanks for looking. If you're looking at the archive, any questions, just ask on Twitter. Yeah, I'm at Twitter. Let's open my Twitter. Yeah, I'm on Twitter. Also, please subscribe if you haven't subscribed. I'm almost like at 50 subscribers, which is good, I guess. But yeah, thanks for hanging out. I think I'll end this stream. So anything, just contact me. I'll take a short break for New Year's. I'll be going to like KL and things like that. So meet you guys after New Year's then. Happy New Year's. Yeah, hopefully you guys had a good 2024. Yeah, just made it 50. Thanks man. Thanks a lot for coming in. Yeah, have a good day. Okay, so I'll call it. Goodbye everyone. Have a good rest of your day. Happy New Year's. Yep, and Merry Christmas as well. Out.